Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. Video we will be learning exercise 4.5 from the chapter Determinants. So in this exercise we will be learning about adjoint and inverse of a matrix. So now let's get started. Find the adjoint of each of the matrices in exercise 1 and 2. So in question 1 and 2, we have to just find the adjoint. So now question 1, a matrix is given and we have to find the adjoint of this matrix only. So solution. So here I will be writing let A is equal to this matrix 1, 2, 3, 4. No. So now I will be finding adjoint of A. So what is my adjoint of A? How will I find? I already taught you in the introduction part, isn't it? Watch that. If you have not watched, please do watch it. I will attach the link in the description box. So here I will be seeing A11 and A22 element alone. So now I will be swapping these two elements. So 4 to the first position and 1 to the second position over here. So I will be writing 4 over here and 1 here. Okay, now what will I do with these two elements? I will be changing the sign of these two elements. So what will I have? Minus 2, minus 3. So that this is the adjoint of A. What we will do is that it is nothing but we will be seeing A11 and A22 position alone. With that position, we will be swapping those two positions and then we will be changing the sign of the remaining elements, that is A12 and A21. So this is the method for 2 by 2 matrix alone. Now let's see how to find the adjoint of 3 by 3 matrix. So this is 3 by 3 matrix. So now I will say that let the given matrix be A. So 1, minus 1, 2, 2, 3, 5, minus 2, 0, 1. So now we will be finding it directly. So we have to take the cofactor only, isn't it? So as I taught you in the introduction part itself, just be very clear so that it will be easy for us to do without lots of steps there. So first I will be taking for A11 only, no? So I will be hiding these two parts. So what is remaining? 3, 5, 0, 1. So 3 ones are 3 minus 0 is 3 only. So here I will write 3. Need not to worry about the signs for now. So this second, no, so I will be hiding these two. So 2 ones are 2 and minus of minus is plus. So 2 plus 10 is 12. This will be 12 and the cofactor for this third element in the first row will be, so 2 zeros are 0, minus of minus is plus. So 2 threes are 6, so plus 6 over here. Next, I will be seeing the second row, first column element. So what is remaining? Minus 1, 2, 0, 1. So minus 1 into 1 is minus 1 plus 0 is minus 1 only. So I will be writing minus 1. So now I will be going to this position element. So what will I do? I will be hiding these two. So what is remaining? 2, 1, minus 2, 1 only. So 1 ones are 1. Minus of minus is plus. So 1 plus 4 is 5. So next, I will be seeing this element now. So I will be hiding the column and the row in which it is present. So what is remaining now? So 1, minus 1, minus 2, 0. So 1 zeros are 0. Minus 2, minus 1 is plus 2. So minus 2 is the answer for this. This is a cofactor. Okay, so now let me take for this element. So I will be hiding the column and the row in which it is present. So what is the answer here? Minus 1 into 5 is minus 5. Minus 3 2s are 6. So minus 5 minus 6 is minus 11. So now I will be moving on to this. So I will be hiding these two. So 1 5s are 5. 5 minus 2 2s are 4. 5 minus 4 is 1. So over here the last element, so the row and columns are hidden. So 1 3s are 3, minus of minus is plus, so 3 plus 2 is 5. The whole transpose, no, so before taking transpose we have to change the sign, no. The what is the formula for cofactor? Aij is equal to minus 1 I plus j into mij, no. So this is the formula we directly did, but only thing we didn't take this minus 1 power m I plus j. Okay, so now what is this I plus j? It represents the position. So if the positions are odd, then we will be getting minus 1. If not, we will be getting plus 1. If it is even, we will be getting plus 1. Okay, so 1 1. So here 1 2, let me write the positions so it will be easy for us. So 2 1 2 2 2 3, but you need not to write all these. Just to teach you, I'm just writing this. So the positions I have written, so 1 plus 1, which is even, so I'm just leaving it. So 1 plus 2 is 3. So minus 1 cube is minus. Now, so I will be writing minus over here. And minus 1 plus 3 is 4. So it is positive. 2 plus 1 is minus. So minus of minus is always plus. So next here it is even position. Then here it is odd. 2 plus 3 is odd. No. So minus will become plus. And 3 plus 1 is 4, which is even. So 3, 2. That is odd, so I will be changing the sign. 3 3 is even, so I will just leave it. So for changing the signs, no, just take this second element, then first and last element and second element. That's it. So only this, just like a square, no, only for these elements you will be taking minus. So if you have negative sign, it will become positive. If you have positive sign, it will become negative. So now let's take the transpose of it. So adjoint of A is equal to, I will be changing this columns to rows. First column to first row. So 3 1 minus 11. Second column to second row. Minus 12 5 minus 1. So third column to third row. So 6 2 5. So this is the required matrix for adjoint of A. Verify matrix A into adjoint of A is equal to adjoint of A into matrix A is equal to determinant of matrix A into identity matrix in the exercise 3 and 4. So the matrices are given. So now let's start finding the answer. So now first we have to find the adjoint of A. So I'm saying that let matrix A is equal to 2 3 minus 4 minus 6. Okay, so now I will start finding the adjoint. So adjoint of A is equal to, I will be swapping these two elements. So minus 6 2, and these two I will be changing the sign, no. So plus 3 will become minus 3, plus 4 will become, sorry, minus 4 will become plus 4. So that's it. This is the answer. So now let's start finding for A, matrix A into adjoint of A. So now what is a matrix A? 2 3 minus 4 minus 6. And what is adjoint of A? Minus 6 minus 3 4 2. So now we will be multiplying. So now let me see the order. So this is of the order 2 by 2, and my second matrix is also of the order 2 by 2. So I will be cancelling out these two. So 2 by 2 is the final matrix order. So what I will do first is that I will be taking only the rows of the first matrix. Since I have two columns over here, I will be taking it twice. 2 plus 3, 2 plus 3. Minus 4, minus 6, minus 4, minus 6. So now I will be multiplying with them first column for the first element. So minus 6, 4, and this also 2. So now minus 6, 4, minus 3, 2. So now I will be doing the calculation. Minus 12 plus 12, and here minus 6 plus 6, minus 24, sorry, plus 24 minus 24, minus into minus is plus, so 12 minus 12. So what is this matrix? Everything is negative of that only. So I will have 0 matrix. So this is my answer for A into adjoint A. So now I will find for adjoint A into A. So adjoint A into A is equal to, what is my adjoint? Minus 6, minus 3, 4 and 2. And my matrix A is 2, 3, minus 4, minus 6. So here I will be taking, this also will be of the order 2 by 2 only. So minus 6, minus 3, minus 6, minus 3. So 4 plus 2, 4 plus 2. So I will be multiplying with this. 2 minus 4, 3 minus 6. So 2 minus 4, 3 minus 6. So I will be doing the calculation. So I will have minus 12 plus 12. Here it is minus 18 plus 18. And here 8 minus 8. And 12 minus 12. So what is the answer over here? Here also 0 matrix of the order 2 by 2. So now let me keep this as equation 1 and this as equation 2. So now what I have to prove in the next is determinant A into I. No, so first I will start finding the determinant of A. So what is the determinant of A? 2, 3, minus 4, minus 6. No, so I will be taking the determinant of it. So determinant A is equal to minus 12, minus of minus. Using X method only I am finding. So minus of minus is plus 12. So determinant A is equal to 0. So my determinant A into I is equal to 0 into identity matrix. So anything into 0 is 0 only. So I will be taking this 0 inside. So as we do for all the sums, so 0, 0, 0, 0. Okay, so this also is equation 3. So now equation 1 is equal to equation 2 is equal to equation 3. Hence it is verified that adjoint A into matrix A is equal to matrix A into adjoint of A is equal to determinant of A into identity matrix. Hence verified. Question 4, a matrix is given and we have to verify. So solution, first let us take the given matrix as matrix B. So this matrix is 1, minus 1, 2, 3, 0, minus 2, 1, 0, 3. So this is the matrix, no? So now first let us find the adjoint of this matrix. So now I will be finding the adjoint of B. So adjoint of B is equal to, so this one is 0, 0, so 0. And for minus 1, 3 plus 2 is 9 plus 2 is 11. So for this element is again 0. And for this element it is minus 3. And for this element 3 minus 2 is 1. For this element 0 minus of minus, so plus 1. So for this it is plus 2. And here minus 2 minus 6 is minus 8. And last over here it is 3. The whole transpose, no, before transpose I have to find the signs for this, no? So sign here I will change. So positive to negative, negative to positive, positive to negative, negative to positive. That's it. Already in the previous sum, that's the second sum, I just taught you how to find all these, no? So only I did it fast. If you have any doubts, just mention it in the comment box. I will make you clear. So B is equal to transpose. This one I will be changing it to rows one by one. So 0, 3, 2, minus 11, 1, 8, 0, minus 1, 3. So this one is over. So adjoint of B is over. So now let's find the matrix, that is B into adjoint of B. No. 3. So both also is of the order 3 by 3, no? So the final matrix also will be as 3 by 3 only. So I will be taking this as, so first matrix I will be taking the rows alone. How many columns do I have? 3 columns. So I will be taking it thrice. So now we will be multiplying with the second matrix. So first elements with first column. So now I will be calculating this 0. So 11. Here everything is 0. And here it is 0. Here 3 minus 1 minus 2. So 3 minus 3 is 0. And here 9 plus 2 is 11. And here 3 minus 3 is 0. So here it is 0. Here also 0. And here 2 plus 9 is 11. So let this be equation 1. So now I will be finding for adjoint of B into matrix B. So now let me multiply it. So I will be multiplying with the second matrix. So now we will be calculating. So here it is 9 plus 2 is 11. Here it is 0. Here also 0. Here it is 0. Here it is plus 11. So 0, 0. Here also 0. Here it is 11. So let this be equation 2. Now what we have to find? Determinant of B. No, so what is determinant of B? It is 1 minus 1, 2, 3, 0, minus 2, 1, 0, 3. So now I am expanding through column 2. So determinant B is equal to, so this is odd position, no? So minus of minus will become plus. So plus 1 into what is remaining? 3 minus 2, 1, 3. So determinant B is equal to 9 plus 2. So determinant B is equal to 11. So now what will I find? Determinant B into the identity matrix. No, so 11 into 1 0 0 0 1 0 0 0 1. So this is the identity matrix. So now I will be multiplying this inside. No, so 11 0 0 0 11 0 0 0 11. So this is the matrix that I got after multiplying. So this will be my equation 3. If we check equation 1, 2 and 3, all the equations are equal. That is, so equation 1 equal to 2 equal to 3. Therefore, these 3 equations are equal. So hence it is verified that B into adjoint of B is equal to adjoint of B into B is equal to determinant B into identity matrix. So hence it is verified. In the inverse of each of the matrices, if it exists, given in exercise 5 to 11. So some matrices are given and we have to find whether it has inverse or not. So I've already taught you how to check whether it has inverse or not, isn't it? So the determinant of the given matrix should not be equal to 0. Yes, no, I already taught you this condition in the introduction part, and we will be using this formula in order to find the inverse. Okay, so not using the matrices method, we will be using some determinant method and adjoint of matrices, and then we will be finding the inverse. So now let's move on to the solution. So now I'm going to write this matrix as, so let the given matrix be A. So my A matrix is equal to 2 minus 2 4 3. So now I will be finding the determinant of the given matrix. So determinant of A is equal to 2 minus 2 4 3. So now I will be using the x method in order to find the solution. So determinant A is equal to 6 minus 4 into minus 2. So here 6 plus 4 2s are 8. So 8 plus 6 is 14. So determinant A is 14. So since the determinant A is not equal to 0, I will say that inverse exists. Inverse exists for the matrix A. So now I will be finding the adjoint of A. So what is adjoint of A? How will I find? So here, let me write the matrix over here. It is 2 minus 2 4 3. So this is the matrix that is given. So I will be taking only these two elements and interchanging it. So 3 2. So here I will be changing the sign. So negative will become positive. Positive will become negative. So this is my adjoint. So now I will what is the formula to find the inverse? So A inverse is equal to 1 by determinant of A into adjoint of A. So now I have found adjoint of A and determinant of A, isn't it? So A inverse is equal to 1 by 14 into 3 2 minus 4 2. So this is my answer. Question 6, a matrix is given. So let me name this matrix as matrix B. So now I will start finding the determinant of the matrix B. So minus 1, 5, minus 3, 2. So determinant B is equal to, I will be using the x method. So minus 2 minus 5 minus 3, no, so minus 2 plus 15, which is 13. So determinant B is equal to 13 and it is not equal to 0. Therefore inverse exists for matrix B. So now I will be finding the adjoint of B. So adjoint of B means I will write the matrix here, 5 minus 3 2. So this is the matrix given. So I will be changing these two elements first. So 2 minus 1 and changing the signs for these two elements. So positive will become negative, negative will become positive. So this is the adjoint of B. So now B inverse is equal to 1 by determinant B into adjoint of matrix B. So B inverse is equal to 1 by 13 into, what is my adjoint? So 2 minus 5, 3 minus 1. So this is my answer. Question 7, a matrix was given and I took that matrix as C. So matrix C only we have to check, and first let us find the determinant of matrix C. So 1 2 3 0 2 4 0 0 5. So in order to find the determinant we have to expand through some row or column, no? So which will be easy for me? I will go through column 1 itself because I have more number of zeros. You can either go with this or any other row. So now I'm gonna expand through column 1. So matrix C is equal to 1 into 2 4 0 5. So matrix C is equal to 10. So matrix C is not equal to 0. So therefore inverse exists. Now I will be finding the adjoint of C. So now here, let me write the matrix over here. So for this element, it is 10. For this element, 0. This 0. Here, 10. 5. 0. 8 minus 6 is 2. Here 4, 2. So now I will be changing the sign. So for 0 I need not to do here minus and minus here. So adjoint of C is equal to 10 minus 10, 2, 0, 5 minus 4, 0, 0, 2. So this is the required matrix for adjoint of C. So C inverse is equal to 1 by determinant of C into adjoint of C. So C inverse is equal to 1 by what was the determinant? 13. No. So here 10 was 10. 10 minus 10, 2, 0, 5 minus 4, 0, 0, 2. So this was the adjoint and this is my answer. Question 8, a matrix is given and let me take this as matrix D. So solution, let's start finding the determinant for D. So determinant D is equal to 1, 0, 0, 3, 3, 0. 5, 2 minus 1. So I will be expanding the determinant through row 1 because that will be easy for us to expand. So determinant D is equal to, this is 1, 1, no, so this is an even position, so I will take plus 1 only. So 3, 0, 2 minus 1. So my determinant D is equal to minus 3 minus 0, it is minus 3 only. So since determinant D is not equal to 0, I will say that inverse exists for the matrix D. So now let's find the adjoint of D. So for this element it is minus 3. For second element minus 3 again. So for this element 6 minus 15. So 6 minus 15 is minus 9. So for this element 0. Second element it is minus 1. Third element 2. This element it is 0. Here 0. Here it is 3. So now I will be changing the sign plus minus, that's it. So adjoint of D is equal to, so this I will be changing this to row 0, 0, this to second row, third row, minus 9, minus 2, 3. So D inverse is equal to 1 by determinant of D into adjoint of D. So D inverse is equal to, what was the determinant? It was minus 3. No. So what is the adjoint here? Minus 3, 0, 0, 3, minus 1, 0, minus 9, minus 2, 3. So this is the answer. Question 9. A matrix is given and I took this matrix as matrix A. So now let's find whether the inverse exists or not. So let me take the determinant of the matrix. So 2, 1, 3, 4, minus 1, 0, minus 7, 2, 1. Since I don't have any more number of zeros, let me take this column where I have 1, 0. So I will be expanding the determinant through the column 3. So determinant A is equal to, So this is 1, 3. No, the position. So it is even position. So I will have 3 as it is. So 4 minus 1 minus 7, 2. And here also it is even. So plus 1 into 2, 1, 4 minus 1. So I will be using X method. So 3 into 8 minus 7. So minus into minus is plus 7. So only minus 7 plus 1 into 2 minus 1 is minus 2 minus 4. So here I will be multiplying this inside. 3 ones are 3 plus minus 2 minus 4 is minus 6. So my answer is minus 3 and my determinant is not equal to 0. No? So therefore I will say that inverse exists for matrix A. So now I will be finding the adjoint of A. So for the first element it is minus 1, for the second element 4, third element 8 minus 7 is 1, here 1 minus 6 is minus 5, here 2 plus 21 is 23, 4 plus 7 is 11, 7, 3 minus 12, minus 2 minus 4 is minus 6. So now I will be changing the sign. So adjoint of A is equal to, so I will be changing this column to row. So minus 1, 5, 3, the second column to second row, third column to third row. So this is the adjoint. What is the formula for A inverse? A inverse is equal to 1 by determinant of A into adjoint of A. So therefore, A inverse is equal to 1 by what is my determinant? Minus 3. So adjoint is minus 1, 5, 3, minus 4, 23, 12, 11 minus 11 minus 6. So this is the answer. Question 10. A matrix is given. So let me take this matrix as B. So now let me check whether this has the inverse or not. So in order to check, we have to get the determinant. So 1 minus 1, 2, 0, 2 minus 3, 3 minus 2, 4. So now I will be expanding this determinant by column 1. So expanding through the column 1. So determinant B is equal to 1 into 2 minus 3 minus 2, 4 plus 3. Since everything is even position, I am taking it positive. Minus 1, 2, 2 minus 3. So determinant B is equal to 8 minus 6 plus 3 into 3 minus 4. So determinant B is equal to 2 plus 3 into minus 1. So determinant B is equal to minus 1, which is not equal to 0. Therefore, inverse exists for matrix B. Now let me find the adjoint. So adjoint of B is equal to, for this one it is 8 minus 6 is 2. Here for 1 it is 9. Here it is minus 6. For this element minus 4 plus 4 is 0. For this element 4 minus 6 is minus 2. For this element minus 2 plus 3 is 1. For this element it is 3 minus 4 is minus 1. For this element it is minus 3. For this element 2. The whole transpose, let's change the sign. Minus, minus, plus. So adjoint of B is equal to, I will be changing this to 0, minus 1, minus 9, minus 2, 3, minus 6, minus 1, 2. So B inverse is equal to 1 by determinant B into adjoint B. So B inverse is equal to, what is the determinant B? There it was minus 1. So minus 1, and the adjoint is 2, 0, minus 1, minus 9, minus 2, 3, minus 6, minus 1, 2. So I will be taking this minus sign inside. So I will get my B inverse is equal to minus 2, 0, 1. Minus into minus will become plus over here. So 2 minus 3, 6, 1 minus 2. So this is the required answer. Question 11. A matrix is given and I took this matrix as matrix C. So now we have to find the inverse of this, using adjoint. So in order to find that, I have to take the determinant. So determinant of C is equal to 1, 0, 0, 0, 0 cos alpha, sin alpha, minus cos alpha. So this is the determinant. So now I can expand through any one of the row or column. So I will expand through column 1. C1. So determinant C is equal to 1 into cos alpha, sin alpha minus cos alpha. Okay, so now determinant C is equal to minus cos square alpha plus sin square alpha. So this also should be minus, no? So determinant C is equal to, I will be taking it out. So cos square alpha plus sin square alpha. And here, what is cos square alpha plus sin square alpha? It is 1. So minus 1, which is not equal to 0. Therefore, inverse exists for matrix C. So now I will find adjoint of C. So what is the adjoint over here for this? Cos square alpha minus sin square alpha, which is minus 1. No. And here for 0, it is 0. Here if we take also, it is 0. And here when we take, it is 0. Here for this cos alpha, it is minus cos alpha, and here if we take it for this, it is 1, 0, 0 sin, so sin alpha, and here if we take, it is 0, and for sin alpha, it is sin alpha, and for minus cos alpha, it is cos alpha. So the whole transpose, now we have to change the sign. So minus, minus, minus. So adjoint C is equal to minus 1, 0, 0. This one, no? So 0 minus cos alpha minus sin alpha, and here this third row, 0 minus sin alpha cos alpha. So C inverse is equal to 1 by determinant of C into adjoint of C. So C inverse is equal to minus 1 by 1 into, so here it is minus 1, 0, 0, 0 minus cos alpha minus sin alpha, 0 minus sin alpha cos alpha. You can leave it with this step, or else you can take this minus sign. No, only 1 is there, so we need not to write minus 1 by 1 and all. So instead of that, we can take this inside also. That is 1, 0, 0, 0, and here minus into minus is plus. So cos alpha, here it is sin alpha, 0, sin alpha, plus into minus is minus. So minus cos alpha. So that's it. This is the answer. If you have any doubts, mention it in the comment box.
Like, comment, share and subscribe.